Okay. Hopefully we're recording. My mic is still working. Okay. So now on to level 3. Okay. We passed level 1 and level 2. We're on to level 3. Here comes level 3. What was level 1? Level 1 was making a probability plot in the calculator without doing any work. Level 2 was using the actual technique of creating the percentiles and finding the z-values and plotting those, which is what the calculator is doing. Okay. I'm trying to organize my work here, but I'm going to give up. Okay, maybe it looks like this. No, my pages are out of order, but it doesn't matter. We're on level 3. It's here. So we're wondering if that graph is straight enough that we can consider the data normally distributed for purposes of doing statistical procedures. To assess whether it's straight enough, we can compute the correlation coefficient, because the correlation coefficient tells you about straightness, and compare it to a table of critical values. This is not the same table we used before. It's a new table, but it looks quite a bit the same. And the reason you can tell it's not the same table possibly is it says here, use of the correlation coefficient with normal probability plots. Now this was published not that long ago. Look at that. You were actually maybe even born then. No, maybe not. That seems like not very long ago to me, but that's, what is that, 26 years ago? Yeah, you were just maybe barely born, some of you, at that date. So we're going to compute the correlation of the values that we use to make the plot. So we're going to do a correlation. Where was it? Oh, no. Was it L2? It was L2 and L4, wasn't it? Here it is. Yeah, so L2 and L4 were the data and the expected values for those data were. Okay, so correlation L2 and L4. And then I forget how to get that. Oh my God, this is not fun. Okay, well, here we go. So we'll quit this and we'll clear that. So someone help me out. How do I get the correlation on my calculator? Uh-oh. Kind of ready. Maybe I'll just slide it up here and then I can compute it in my head. No, it's not working. I'll try again. Correlation, how do you get it? So I'm thinking, you know, stat, calc, right? I wonder if two variable stats will give you correlations. Does this correlation show up on this list? I don't think it does, right? But they're not that nice. There's all kinds of stuff there. Two variable statistics, it might do it. We could try it. So we picked L1 and L4. You know, if they were smart, they'd give us correlation here. But it's not there, so the calculator is not being friendly. Do you remember where to go? I actually do know. You might guess that. Yeah, I actually do know. We did it before. It was a long time ago. So the where you go is to stat, calc, an unusual place, linear regression. That's right. And then we go L2 and L4 are the variables that we were interested in. The data was in L2 and the z-values were in L4. We're not going to use this for anything except to find R. There it is. So R is 0.9685. Cool. Dredged up some old memories. And then we compare that 9685 to the table. So the table says sample size is 12. Here we go. Our sample was n equals 12 values. So we had n equals 12 points. Okay. And so we'll compare our 9685 to that 928. So it says if R exceeds the critical value we consider the data to have come from a normal distribution. So this 965 is bigger than 928. Since it is larger, our data can be considered normal. Since it is larger, R equals 0.9685. So larger than the 928, the data can be considered normal. So that gives us a pretty well hard and fast way of determining whether we can go forward with a statistical procedure. Ordinarily, we don't care that much. Ordinarily, if the graph looks basically linear, we're good. So we saw with our pictures that normal looks like a straight line and skewed looks like a curved line. So if it looks basically straight, we don't have to go through this process. But that's the process that statisticians use if they want to put a number on it. I can't see my R here. There we go. You would do this test by computing R and compare. So we did the same kind of thing. We want to check whether the data is linear by accident or if it seems to be linear for a reason by computing R and comparing it to another table. Here it was the same kind of thing. Want to see if the data seems to be coming from a normal distribution or if it's too badly skewed to be considered normal. So as long as you beat this number, then the graph is considered straight enough that the data is considered normal enough that the curve we might see might just be random as opposed to being caused by something from a distribution not being normal. And there we are. I think that is the end of this day. I'm going to take my most fancy computer setup ever here and close the sharing. I'll stop the recording.